All right, good morning, guys. So today we're going to do a lesson on simplifying radicals. And there's a lot of things we're going to talk about here. Some things I think pretty much all of them are pretty easy. Yeah? Some of the stuff you start using throughout higher level math. Some of this will not even be on our EOC, but I thought I might as well show it to you because you're going to need it in geometry next year sometimes. Okay? So kind of like a little variety of things dealing with radicals. Some of it you already know, right? I guess the first thing we need to do is make sure you remember how to simplify a radical, right? All right, so if I have the square root of 32, right? Remember what we do. We break the number down, right? Is 8 times 4, and that's 8 is 222, and 4 is 22. So 1, 2, 3 2s, and another 2 2s. And then remember, you take out pairs, right? Pairs of 2s. Pairs of 2s. I thought I was recording your screen. So you're looking for pairs of 2s. All right, so 32 breaks down to 2, 2, 2, 2, 2, right? Take out 2 pairs of 2s, and you have what? 4 square root of 2. That's the simplified version of it, yeah? All right. Now the next interesting thing. Let's look at 2 to the first, and let's look at 2 to the 0. And then let's look at all right. 2 to the first is what? 2 to the 0? Okay, now here's the weird one. Math team, you got to be quiet. Okay, so what kind of numbers are between 1 and 0?
Decimals.
Or fractions. So the question is, what would a number to a fractional power be? And I actually, in second thought, it's better to deal with 4 to the 0 and 4 to the 1. Yeah? 4 to the 1 is? 4 to the 0 is 1. Yeah? So a fractional power of 4 would be somewhere between 0 and 1, right? So 4 to, like, say, the 1/2 power. Yeah? All right? What do you think? Okay, so the question is, why is it 2? It is 2. If you type this into a calculator, right, you get 4 to the 1/2 power, and it says 2. But why is it 2? In fact, what's happening, all right, 4 to the 1/2, at the deeper level, the top of the fraction is the power, the bottom of the fraction is the root. So it's really saying 4 to the first power square rooted. We don't normally write this 2 here. It's implied. If you put a square root, it's implied that it's a second root. But there are things called third roots, cube roots, right? Fourth roots, fifth roots. You can start getting into them, yeah? But for us, we don't write that 2 usually. It's just implied that it's a second square root. But you could have a third root. Yeah? And that means what number times itself 3 times makes that number. Yeah? All right. So when you see a fractional power, that's really a type of root. So for example, if I had, we're not going to do this tonight, but if I had 8 to the 1/3 power, that would mean 8 to the first, and what kind of root is it? Cube root. Which means you have to take 3 of the same thing out. And we're not going to get into cube roots today, but that's the idea behind it. What are fractions? Okay, so we know negative powers are decimals, right? Negative powers are decimals, right? They had such a good program, and their program really sucks now. It's buggy as heck. I'm actually going to give up on their program very soon. All right. So that's the first thing you need to get. When you see square root, when you see fractional powers or 1/2 power, what does it mean? What does a 1/2 power mean? Yeah, it means square root, basically. And we didn't add that to our notes, but it's on my other version of the notes, right? So let's add this. A to the 1/2 is equal to what? A to the first, well, square rooted. Okay, so anytime you see fractional power, just turn it into a square root. Anytime you see 1/2 power, turn it into a square root. Is that easy? So let's go down. We'll start with this number 11 real quick, right? I see 4/9 to the 1/2 power. What does that mean?
4/9 to the first.
Yeah, don't worry about the first. It does nothing, right?
Yeah.
So it's just the square root of 4/9, and that's easy, right? Because you would do the square root of the 4 over the square root of 9, which is 2/3. The 2 is here. But like I said, when we don't write it, it's always implied that it's a 2. We've been doing it our whole lives. Square roots really has a 2 here. We just don't write it because it's if you don't see it, it means 2. That make sense? That's a good question.
Maybe that's why it has the little thing like this.
I think it's just a symbol we made up. But the implied 2. So every one of these has a square root. What kind of root? Second root, third root, fourth root? Which ones? Every one of them has a root. Well, which one is it? There's nothing there. There are always 2. We just don't write it when it's 2, yeah? If it's third root, you would write it. You would put a little 3 there, yeah? All right, next part. The only roots you can add are if they're exactly the same. Think of them as fruit. Think of root 2 as like x almost. Don't write this, but think of that as like 5x plus 3x. What's 5x plus 3x? You would think in your mind 8x, so it's really what? 8 root 2. And now you don't have to convert them to x's. Just think of them as a variable, yeah? What's the only thing you can add root 2's to? Yes, it's easy. What's the only thing you can add root 2's to? Root 2's. All right? All right, so how many root 3's is here? 1. 1 root 3 minus 4 root 3. Wow, you suck at subtraction. -3 root 3. Done. Okay. Example 4. All right? You can't add them yet, but what if I simplified root 12, and maybe it turns into something I like, right? So let's try it. 2 root, what does 12 break down to? 2, 2, 3, all right? Plus 4 root 3, we can't do anything to that.
Oh, you can just pair it up.
So what do you notice? We have a pair of 2s. So what does that mean? Take a pair out, right? See it? Now what's left? 4 root 3 plus 4 root 3. Okay, stop. Make sure that makes sense to you what happened. I simplified root 12 to see if maybe they simplify to the same thing, and they do. So now I can add them. So 4 root 3 plus another 4 root 3? 4 of those plus 4 of those makes 8 of those. 8 root 3. That's easy. It's not hard.
Or you could have done
All right, what about this next one?
okay, this one we are gonna have to simplify both.
All right, so let's simplify them both, right? So 32 is 8 times 4, right? And what's 8 break down to?
2, 2,
2,
2.
2, 2. And what's 4 break down to? 2, 2 minus 5 root. What's 50 break down to?
5.
Okay, and what's 10 break down to?
2, 5.
All right, so it's 2, 5, 5. I would have done 2 times 25, right? When you do these long enough, you start realizing, oh, usually if they're making you add them, subtract them, when you simplify them, they're going to be the same root, yeah? So, pair of 2's, take a 2 out. Pair of 2's, take a 2 out, right?
Wait, why did it say 2 times?
There's a time sign there. See it? Okay. What can I take out of the second one? So this is 4 root 2 minus, what can I take out of this?
5.
Take out of 5, right? So this is what? 5, 5 is what? Wow.
25.
Your National Bad Answer Day. Congratulations. All right, 4 root 2 plus 25 root, or sorry, 4 root 2 minus 25 root 2.
Negative 21.
Good job. We'll keep you anonymous in this video.
I'm pretty sure we all know who it is.
All right, here we go. So negative 21 root 5. Is this hard? Question?
National Baptist
Emily?
Trinity. Don't feel bad.
Oh, I don't know how I got root 5. Good catch, Emily. What is it? Root 2. Thank you.
That wasn't too bad.
All right. Now, multiplication, right? Like a Punnett square, right? We're not going to do, you could do Punnett squares with these, and they're kind of, they're not actually that hard. But you can distribute roots the same way. Yeah? Okay? All right. So this would be root 3 times 2, yeah? Minus 4 root what? 3 times 3, yeah? What did I do? Root 3 times root 2 is root 3 times 2. Root 3 times 4 root 3 is negative 4 times root 3, right? Make sense? So you can just multiply the roots together. And there's a really logical reason why you can do that. I'm not going to get into it here. Just take it on fact. When you understand math higher, it's pretty obvious why that would work. Yeah? All right. So what does this become? Root. Okay, what does this become? Be careful. Okay, don't do root 9. It's already broken up. So why bring it together so that you can break it up? What do you have? A pair. So take a pair out, right? So this is root 6 minus what? Minus 12. And then I want to simplify that, right? How do I add those together? What's root 6 minus 12? You're done. You can't add root 6s to whole numbers. They're not the same fruit. So root 6 minus 12. Is that easy? Yeah. All right. Pencil down for a minute, please. Okay, when you get into higher level maths, right? Even Algebra 2, even geometry will do these. Every time I try to... No, their software is crap now. Look at it. That's going to be a crash. All right, I'm not gonna do that anymore. All right. In higher level math, you will start getting stuff like this. You'll get fractions, and inside the fraction is a root. It's okay if there's square roots in the numerator. It's not okay if there's square roots in the denominator. The reason that I've looked into, like, why don't we leave square roots in the denominator? The reason behind it has to do with math before calculators were invented, and that it made the math easier. These days, there's really no good reason to do it other than we do it, which kind of sucks. But we don't leave radicals in our denominators. Yeah? All right. Just like any number, so if I took the 2/3, what can I multiply 2/3 by and not change it? Let's not get too clever. 1, yes? 1? No, -1 would change it. It'd become a negative fraction, yeah? If I multiplied it by 1, it would not change the fraction. That's why when we multiply by 2/2, we're not really changing the fraction. Because what is 2/2? I'm just multiplying by a weird 1, right? 2 times 2 is 4, 4, 6. Oh, yeah. Welcome to, like, 4th grade, maybe? You were doing that? You probably didn't understand why it worked at that point, right? But you were just multiplying by a weird 1. Okay, so you can multiply this by a weird 1. You could multiply this by 2/2. The problem is it doesn't help you. Because 2 times 2 is 4, and root 2 times 2 is 2 root 2. Didn't help me. No, it didn't. So you play with it for a while, you're like, well, what could help me? Well, what do I not like about this problem? The root 2 on the denominator. How could I get rid of a root 2? Look what would happen, and it was not intuitive the first time. What would happen if you multiply by root 2 over root 2? Which is a weird 1, a very weird 1.
A really strange one.
Yeah? Now watch what happens. You get 2 root 2 over root 2 times 2, right? Because you can multiply the denominator. You can multiply them. And what happens? You have a pair, and you take them out, right? So you're left with 2 root 2 over 2. The 2's cancel. You're left with root 2. That's weird, huh? 2 over root 2 is the same as root 2. That's not intuitive at all. Right, let's see if that's true. 2 divided by root 2 is some weird number, yeah? And then just root 2. Same answer. They are equal, yeah? So that is how you that's called rationalizing a denominator. And you'll do it in geometry next year, periodically. You cannot have radicals in your denominators, all right? So if I had, I don't know, whatever, 5 over root 3. If I want to get rid of the root 3, what would I multiply by? You can't multiply by root 3 because that's not 1. What can you multiply by? Yeah, you said it later, right? Root 3 over root 3. And that becomes what? 5 root 3 over root 3 makes 3. Not root 6, Caitlin.
That wouldn't even make sense.
So 5 root 3 over 3. You see how we're doing this? It's actually quite easy. So, and that's what the notes say, right? They say, right? You cannot have radicals in your denominator, right? So let's go to this one, right? So what am I going to multiply this by, right? So I'm going to take 7 root 2 over root 2, and what am I going to multiply it by? Root 2 over root 2. And let's, in our notes, let's write this. This is a weird one, right? Yeah? I'm going to write this out, but you don't have to write all this out each time. Just see it the first time. 7 times root 2 makes what? 7 root 2 over root 2 times 2. Yeah? So 7 root 2 over, take out a pair of 2's, and that's the whole point of that, was to get rid of the radical in the denominator. And I can't simplify 7/2, so I leave it alone. Yay or nay?
Yay.
All right, next problem. All right, what's the problem with this one? That's not 1/2. Because root 6 is not the same as 6. No. It's not 1/2. Good idea, though. If it was true, it'd make life a lot easier. All right, so we're going to take 3 root 6. What are we going to multiply it by?
Root 6. 6 over 6.
Root 6 over root 6, because that's 1. So I get 3 root 6 over, what's root 6 root 6? The whole point is to make a whole number, 6. Now what? What's 3 6 really?
1/2.
Okay, so that's going to be 1 root 6 over 2, but what's the best answer?
Root 6 over 2.
Root 6 over 2.
How is the 1?
Because 3 root 6 over 6 is the same as 3 6 times root 6, yeah? That's the same thing? Yeah? And that's 1/2. No, you really weren't, because there was a root 6 there. You didn't say, it's not 1/2, it's 1/2 times root 6, but if you had said that, I would have said, hey, good job that you did that in your head. That's not what you said, though. All right, what do I do with this? I can square root each one separately, yes? So I'm going to first start off like this. Now, they're both ugly, but one's not allowed. Which one's not allowed? The root 6 on the bottom. I don't care if there's a radical in the top. I care if there's a radical in the bottom. Yeah? So, what am I going to multiply this by? Multiply by a weird 1. Root 5 times root 6. Which is, okay, and then think about 6 real quick. What is 6? So that's 2, 3, 5. Is there going to be a pair in there?
No.
So it's just going to be root 30. Over? Okay, now the million-dollar question, can I simplify that? Can I simplify 30 and 6? No. If the 30 was outside the radical, yes. Inside is just like a new fruit. Yeah, it's like a new variable. It's not the same, exactly. Got it? All right, let's make it a little bit harder. Ready? Okay, so let's break these up into 2 problems, right? So this is root 3x squared over root 8. Okay, break them down, right? This is 3xx, and this is what? 2, 2, 2, yeah? All right, so let's take out pairs. Take out an x, right? Take out a 2. Okay, so now I'm going to write it down here. I get x root 3 over 2 root 2. Now that may look like it's a good answer, but it's not.
Because there's still a root on top.
So I got to multiply by to get rid of that root. How? Root 2 over root 2. What about the root 3?
That's fine.
Who cares? So this is x root what? Math team, kind of give them a thinking time, okay? You guys understand? Yeah, because you just multiply them. So 6. And this is 2. And then that's root 2 times root 2, right? I'll write it out for us, but that becomes 2 when I bring it out, yes? Root 2 times root 2 is 2. That's the whole point of this, right? So what do I end up with? X root 6 over 4. That's it. And listen, if these popped up on the EOC, you could just check it, right? You could say, ooh, I think it's this. I could plug in a number for x, see what it equals. Plug in the same number for x here, see what it equals. If they equal the same thing, you know it's right. You can get a homework on you can get 100 on your homework tonight. Yes. All right. Okay. So remember what we talked about a few minutes ago. Fractional powers are just what? Square root. So this is root 4 over root 9, right? So fractional powers, this means square root, yeah? And that becomes 2 over 3, right? All right, let's do the last one. You're going to have a few of these on your homework too. Okay, so what does this mean? This is way past what you're going to see on the EOC. But if you can do this, you already understand it at a pretty high level. Okay, what does that fractional power mean? Okay, so that's just really the square root of 3x squared over 20. Yeah? Okay, so I'm done? No. Break them down. That's what? Square root of 3x squared over square root of 20. Okay, stop there for a minute. Make sure it makes sense what I just did. Oh, I see a 1/2 power. That means square root. Yeah? Then break it up into two problems, right? So this becomes 3xx over root what? What's 20 break down to? So it'd be 4 times 5, and 4 breaks down to 2, 2, right? So 2, 2, 5. Let's go slow here. We don't have to rush. You following me okay? Okay. Take out the pair of x's, so that's x root 3. Take out the pair of 2, so that's 2 root 5. And yay, that's my answer, right?
No.
No, it's not. What's the problem?
The root 5.
The root 5. So what am I going to multiply? A weird one. Which weird one? Root 5 over root 5. So this becomes x root 15 over 2 times, what's root 5 root 5? 5. That's why I did that. So I end up with x root 15 over 10, and that's my best answer. And that is way past, I think, anything they'll ever ask you on an REOC. But when you get into geometry and algebra 2, that's how you simplify radicals, okay? What they will ask you on the EOC is this. And I remember this one year it popped up on the EOC, and I had not taught it to my students. And they still all got it right. You know why? Because all they did, I don't know what that is. I don't know what that means. They made up a number for x. They plugged it in, see what it equaled, and then they went through every answer choice and figured out which one gave them the same answer. And they knew nothing about square roots that were fractions. Yeah? Make sense? All right.